Okay, hello everyone. Can you guys hear at the back? Is that okay? Yes? Yeah, somebody can hear. Fantastic. Thanks for taking time out of your lunch break here at Devox to come and listen to this quickie on Lambda Behave. Lambda Behave itself is a project which kind of kicked off originally for me when I was writing a book back at the end of last year on Java 8 and Lambda expressions called Java 8 Lambdas with O'Reilly Media. And I was trying to think of a really good example of how you can write kind of more fluent APIs in Java 8 than you could in previous versions of Java, and things which are a bit nicer, a bit more friendly to use, and have something that was a little bit more of what some people might call an internal domain-specific language, which is to say a DSL that's not something you're parsing and bringing in from an outside source, but something which is just based upon you having APIs that read and look like the thing that they're doing, the domain that they're talking about. And it struck me that actually testing and specification frameworks were a really good example of the kind of area in which we can really benefit from this kind of style. So as I wrote this framework, and then I decided, well, you know, I've got a framework, you might as well open source it and get it out there and get some people using it. So it's on GitHub, on github.com/richardwarburton/Lambda Behave, if anyone wants to check it out afterwards. And from now on, I'm just going to live code a few examples to show you what the API is like and to show you how you might want to use the framework. Okay? So we're going to write just a very simple test for just a stack, just a bog standard Java stack. And tests in this case follow in many ways a similar model to the JUnit model, where you have a suite and each suite has a bunch of tests within it. So if you want to start a suite, you start typing suite.describe, so suite's just an interface in the API, and then you provided a name. And one of the key points about Lambda Behave is that you're not restricted to fitting into this idea that everything has to follow the method name rules. All the names for everything follow strings, and you can write arbitrary things in whatever your local language is, whatever your internationalized language is, and also using fully formed sentences that describe clearly what it is that your specification is actually doing or saying. So let's just start off with a stack. Usually we statically import the describe method. So that's how you start kicking off the idea of a suite. And you'll notice that the second argument I've passed to the describe method is a Lambda expression. So it's an anonymous function that we call. And when it's called, it tells Lambda Behave, here's how we describe our specifications about our stack. So it should be empty when created. That's the kind of thing you might want to say about a stack. And that method also then takes some kind of Lambda expression which lets you describe that specific test. And it takes an argument, and the first argument is an expectation. And the expectation is something which is basically a fluent API for describing things about the object. So for example, we can say expect that our stack is empty. Okay? And then if we run this test and we cross our fingers to the demo gods, everything passes and everything goes green. Now it's worth flipping back a second and saying what's actually happening in this test. So quickly, hands up, does anyone use the Hamcrest matches? Some people. I really like the idea of the Hamcrest matches. I like the fact that you can say, hey, not just assert equals 11 and something size, but you can say, hey, here's the size of a collection and I really want it to be 11. Because when that test fails, you get a really good diagnostic. You can immediately go in and it'll tell you what's actually gone wrong, what's actually failed in this case. But the thing is, I have a really awful memory. And I've got a lot of things which I want to try and remember and fit into my memory. So for me, having all those static imports and remembering the names of everything is a real burden. So the expectation style in Lambda Behave ends up having a series of overloaded that's for different forms of, for different types of object. So when we're saying expect that stack, we get a series of IDE-supported nice methods which we can easily autocomplete, where our IDE is doing that remembrance for us. Okay, let's just write a couple more specs just to show the style. So again, it should pop the last element pushed onto the stack. So again, let's get an expect going on and take our stack and then push 1, and we're going to take stack, and we're going to push 2, and we're going to expect that stack.pop is 2, right? And that's fine, and that will pass. That's all good. So that's just just a slightly more complicated spec. Obviously, because those callbacks can have an arbitrary block of code in, you can write things which are as long or as short as you want. Now, one thing we've done here is we've been modifying the state of our stack, and that stack actually, the way this has been written, the stack object actually ends up being shared between different instances of the tests. So if we want isolation, we need to ensure that that stack gets cleared out. So there's a couple of methods that are called isSetUpWith, which an isSetUpWith corresponds to something that gets run before each test. So we can just say stack : clear. So that's a method reference to say clear the stack and do the setup with it like that. We can also say is concluded with if we want something to run after each specification, and we can also say initializes with if we want something to run at the beginning of the suites. So that's the equivalent of JUnits before class, and completes with which runs after the suite. So that's the equivalent of JUnits after class. Okay. A few other things which are worth noting is that this code is all in the anonymous initializer function, which is an interesting choice on my behalf, but it seems like the most appropriate thing in this situation. And the other thing is all of these tests which we've been running have been run with a JUnit runner. So if you have a situation where you've got a bunch of tests in a project which are JUnit, and maybe you want to use some Lambda Behave, or you might want to have some of your behavioral tests written in this more fluent style, you can get that to completely integrate with the JUnit suite and have results all in one, in one combined report. It also means it works perfectly fine in this IDE, and it'll work fine in pretty much anything that supports running JUnit tests. So Eclipse will work fine, Maven, Gradle will work fine, you can get it to hook into your CI server and run tests on your CI server. So even though it's not a project that's been out there for very long, a lot of these barriers to adoption and maturity issues we've already overcome by piggybacking JUnit. There's also support for, does anyone here use Scala test? 2, 3 people. There's also support for hooking into the Scala test framework, which means if you're in a situation where you've got a mixed Java and Scala project, you can carry on using Scala test to test your Scala code, and you can use something like Lambda Behave to test your Java code. That might be an appropriate choice. But fluency isn't the only thing we're going for here. We want to add a couple more features or make certain types of testing which are currently quite painful with JUnit be a little bit more flexible, a little bit nicer. So one of the things which I do from time to time is write a test that's a data-driven test. So that's the thing where you want to run the same kind of check but with different inputs and outputs. And that kind of situation in JUnit is really painful. You either have to use theories or app parameterized, and both have serious kind of API usability issues, in my opinion. So let's start off with suite.describe the max function. So this is obviously a very, very simple example, but it's a 15-minute talk, so I hope I can be excused that. And we're going to describe the max function, and we want to put a bunch of input numbers in, saying here's the 2 inputs to a max function, and here's the output value that corresponds to the match. So we have support for doing that in Lambda Behave by doing things like it uses 1, 3, 3, and -7 for 4, and 0, 0, 0. So, different cases we're testing here, just a basic max, something with negative numbers, and something where they're both the same. And we want to say to show, and then again we're going to take a callback here, which is parameterized by those different columns of data. So we want to show the max function returns the larger number. And then our second argument here is going to be a callback. So we're going to have an expect, left, right, and answer. And then what we're going to do at that point is just say expect that math.max left right is our answer. And then if we run that, we can see that you'll have 3 different specifications generated, each with the different input values. And you'll see at the end of the name of the specification, you can see what input values are run, so you can see what tests failed. But that's not necessarily the ideal fluent way of doing things, so we actually use method names for parameterized tests or also format strings. So we can say, the max of the first 2 arguments returns the third argument. And if we rerun that test, we'll see that we've got a bunch of auto-generated test instances that are appropriately named with the different data that we've put in. And again, that's a naming property that will work across your different build systems and IDEs. Just a quick demo. A third thing, which is something like a kind of like a property-based testing situation, although I generally prefer to refer to it as auto-generating your test data. So a simple example in this space is let's suite.describe strings. And what we want to say about strings is that when you reverse them twice, they're going to return the same string. But we don't want to have to specify this whole block of different strings to all reverse twice. So let's say it requires 10, so that means 10 different examples with an example, and we're going to provide a data generator here. So that's a thing that tells you what are the types of things that are going to generate. So if we just go to the generator interface and say ASCII strings, so it requires 10 example ASCII strings, and then to show that the string reversed twice is itself. Okay? And then we'll take expect and a string, and we will take a callback here. And what we're going to do, because it's Java, unfortunately, is we're going to have to say new string builder str .reverse .toString. Fantastic. And that's the result. And then expect that str is result. And then when we run this test case, we can see we'll automatically generate a bunch of 10 different input values here, which are all different types of ASCII strings. Maybe 10 isn't enough to generate confidence, so we'll run 100. Lovely. Now, suppose this was a function that failed in some way. You'd want to be able to repeatedly debug and check why this function fails. And some of the idea that you're randomly generating these input strings doesn't necessarily gear that well with the idea of repeatable, deterministic, reliable testing. So what we do is we print out the seed of the random number generator and also have an abstraction in the framework that lets you provide a different source of randomness. And we want to say with source, I'm just going to go with source generator.random numbers. So, and I'm going to plot the seed in from the last run. So you can see that the top 2 entries on the previous run were IP and @ question mark, something crazy there. And now, having set the seed deterministically, we can rerun these tests and IP @ question mark. And we can, that's not just me running them rapidly, I can rerun them an arbitrary number of times, and we'll still get that deterministic output. So it gives you the option of exploring the problem space and coming up with test cases which you wouldn't necessarily have thought of yourself, but still maintaining that deterministic, repeatable testing that you might want to use when you're putting your tests through your CI framework. So That's the end of this quickie talking about Lambda Behave. I hope you've enjoyed it, and I hope you find that the framework fluent and useful and perhaps something you might want to think about yourself. And thank you very much, guys. And if anyone has any questions, I think we're about out of time, but come and ask me afterwards. Okay.
Cover you, engrave it, cover you, engrave it. Let the bear you melt in the mud. Dip your toe in the mud. Stir it with your foot. Across the muddy water. Sisters and brothers. Let the bear you, let the bear you, let the bear you melt in the mud. Dip your tongue in the dirt. Slide across the surface. Across the muddy water. See what it tastes like. The mamas and the papas are still a strong match. The brothers and the sisters are still a strong pack. The movers and the shakers are totally whacked. And me and you are still a fact. The mamas and the papas are still a strong match. The brothers and the sisters are still a strong pack. The movers and the shakers are totally whacked. And me and you are still a fact. Slide your legs in the mud. Let the grease work your skin gently. Let the bear you, let the bear you, let the bear you melt in the mud. Slide your foot in the water, strangling your ankle, move it side to side. You know when you hit the spot. You know when you hit the spot. In the mud. The mamas and the papas are still a strong match. The brothers and the sisters are still a strong pack. The movers and the shakers are totally whacked. And me and you are still a fact. The mamas and the papas are still a strong match. The brothers and the sisters are still a strong pack. The movers and the shakers are totally whacked. And me and you are still a fact. It's gotta be down there somewhere. It's got to be down there somewhere. It's gotta be down there somewhere. You know when you hit the spot. It's gotta be down there somewhere. It's got to be down there somewhere. It's gotta be down there somewhere. You know when you hit the spot. The mamas and the papas are still a strong match. The brothers and the sisters are still a strong back. The movers and the shakers are totally whacked. And me and you are still a fact. The mamas and the papas are still a strong match. The brothers and the sisters are still a strong back. The movers and the shakers are totally whacked. And me
Thank you. Oh. I'm missing. Okay, let's get started. Thank you all for coming. My name is Jérôme Daucher. I work on the Android Tools project at Google. And today I'm going to talk about the manifest merger. So it's one of the tools which is present in the tool chain for building Android applications. And this is particularly useful when you're developing an application which is either using a lot of variants, meaning you want to have a pro or free version, stuff like that, or which is importing a lot of libraries, or both. And when you are in such cases, you most likely need to merge Android manifest XML files. And there used to be a tool in the previous version of the tool chain which was rather simple, which could not really merge library files and stuff like that. So we completely rewrote it, and we added a lot of customization capabilities to it so that it would be a lot more useful. And hopefully you guys will have less and less hard coding or hand doing of these manifest merging activities. So I'm going to go through merging different XML files in front of you. There's no slides. And I'm going to show you how you can actually customize the tool to fit your needs. So the first thing I'm going to show is you've got an application here which has its own Android manifest, obviously. And it has an activity. There's nothing too difficult here. This application, as you can see inside the Gradle here, is having two libraries. And when you look more carefully, you can see that there's two flavors, flavor 1, flavor 2. And the lib1 is imported only for the flavor 1. The lib2 is only imported for the flavor 2. So right now, I'm just going to build the flavor 1. So lib1 only is interesting, and this manifest file here will then be merged into the main manifest file. So I've got another editor here which shows the resulted merged activity. So this is where we're starting from. So if I build my project, it's not going to do much right now, but basically this is the version that I just merged, right? So you recognize the first activity from this Android manifest. There's an activity here, and there's another activity here, and I merged the two of them. So let's see how this happened, because, for instance, there is this tools replace customization that I have added. And if I remove it, let's see what happens. So if I try to build now, I'm going to get a build error, because what's happening is that the main manifest file is defining an icon and a label, and so is the library. As you can see, it's redefining an icon and a label. So this is the first thing that you will probably run into when you start merging XML files, is that you've got conflicting attributes in two different Android manifest files. And when I say conflicting, they have to have a different value, right? So if they had both defined the same attributes, but they both had the same value, we're fine with that. We're not going to generate an error. But if they have a different value, this is conflicting, we will generate an error and we will fail the build like we just showed. So that's why you need to then tell to the tool that you want to actually, you want to, okay, let me retype it. You wanted to replace, right. Sorry about that. Okay, why is tools red now? What did I do? Oh, come on. The demo gods are not with me today. Okay, well, sorry about that. I'm going to lose a little bit of time here. Good Lord, I am prudent. I know me, so I have a backup copy of the entire project. Come on, come on. Yes, reload the project, please. All right. So we're back to the first version where I had my tools node. Sorry, not this one. Where I had my tools replace right in place. Okay, so now if I do it again, it's going to build. So that's the first thing you're going to find the need to customize for. Now we're going to get into some more, some different type of customization. Let's go back to the Android view, and let's go to the lib again, to the manifest file here. And you see there is an activity here in my library. It is a rather simplistic example, but let's say that your library has several activities, and you're really only interested in bringing some of them into your application. You want to remove some of these other activities which are not useful for that particular application. So the way to do it is to come back again to your main manifest file, and you have to say something like activity, and you have to give the name of the activity. So that's the one that comes from this library. So here I give the entire name, and you can give a tools node remove annotation. So when I say this, when I tell the manifest merger this type of things, I tell it that if there is any activity with that particular name being merged, just remove it. So let's go back to the current version. This is the current version of the merged XML. As you can see, there's two activities here, one after the other. Let's save this. Let's rebuild. Let's look at the console. Okay, it's successful. Let's go back here. Bingo, you've got only one left. Okay, so you can selectively remove sub-elements of the XML files you're merging in. That works for activities, but it works for anything else, right? You can remove permissions, you can remove anything you want, but you just have to give the right key. If you were to say something like remove all, then you do not need to give the key here. You could remove that, and you could say, I want to remove all activities coming from any libraries that I'm merging. Okay, so you can remove all the incoming stuff if that's your desire. Another thing you can do is strict. So when you define a node like this as being strict, that means that only you can define this particular activity. Only this particular app can define it. And if it tries to merge a library which redefines it, it should fail. Even if the values are the same, it doesn't really matter. You should be the sole definition of this particular activity. So if I try to build now, it will complain that, that this activity has a strict merging policy and that it's defined in the library, so it's refusing to merge it, basically. Okay? Another thing you could do is to say that you only want to merge attributes. So if we go back to the library, you see the library has this activity, and it has a child, which is the intent filter. Once I have changed the main manifest file to say that you only want to merge attributes, and you rebuild, this time it passes, of course, you can go back to the merge once, and you can see that now you only have the activity without its children merged from the library. Okay, so again, it's a flexibility that you can use. We also have merge only children, but it's not very useful for most people. So most of the people will use the default, which is implicit. So this is equal to not provide anything. So if I do that, I'm going to come back to the original state where I didn't have any type of annotation for this activity coming from the library. Okay. Another thing I want to show you is some implicit declarations that get added by the manifest merger. So when you are in a situation where you are importing a library which was targeting, for instance, version 1 of Android, there were things that were implicit in such runtime. Such permissions, for instance, like access to the storage or things like that. So the fact is that these libraries were not defining those permissions because they were implicitly defined or granted by the platform. But when you import these libraries inside your application, if you do not define these permissions, these libraries will not function correctly in a newer environment. So if you try to run it in ICS or in Lollipop, you must explicitly set those permissions so that the library can function properly. But we're going to do that automatically. So for instance, let's go back to my Android manifest here, and then I'm going to start saying that this library had a mean SDK of 1. Now I can rebuild. I can look at my merged file, and as you can see, 3 permissions were added automatically. Okay, so those permissions were the ones that were automatically granted at version 1, and because now you are targeting a newer version of the platform, here I'm targeting 15, they get automatically added. All right, so that's something that you must be careful about and understanding where those extra permissions are coming from. Now, let's take the other case where you are going to import a library which says now it only supports 21. So here you potentially have a problem. You're trying to build an application which is targeting 15, and you're trying to import a library which can only work on Lollipop. So in theory, this should not work. And in practice, it does not, right? So it's going to tell you, you're trying to build for 15, you're trying to import something that requires 21, it's not going to work. So that was like, our initial feeling on how things should work, but then, obviously there are cases where, yes, you're importing this library which seems to require 21, but really you're only using a feature which works fine on 15. And so, this requirement of forcing everybody to then extract this specific feature into yet another library and make that, being only 15 type of library and then import that, we thought it was a little inconvenient. So we decided that yet again, you could customize this particular use SDK to say that you wanted to say that you authorize that this particular library can be imported. So if you look at the library, where am I? Yes, okay. So here you have to take the package name, obviously, of the library. So this is the package name of the library. Go back to the main one. And now you say that you authorize this library to be imported even if the versions are theoretically conflicting. And now it passes. And obviously, if you go back here, you can see that the mean SDK is 15, not 21. Right? It's still 15. And you have to be yourself very careful about which feature you're going to be using of this particular library, which was supposed to require 21. Okay? All right, so another thing I wanted to show is, go back to project, and let's close this guy for now. I wanted to add, say, I'm going to go to the flavor one, and I'm going to add a new activity there. I'm going to call this my main flavor 1 activity, maybe. Okay, good enough. Obviously, it has added a new Android manifest in flavor 1. So this Android manifest is what we call an overlay manifest. So this is something that lives above the application, the main manifest file, as we call it. So when you are merging, you're merging the main manifest file, and above it is all these overlays, comes from all the variants and all the build types, and then under you've got the libraries. And so this hierarchy of Android manifest will decide who wins when there is a conflict and who needs to be annotated when there is a conflict. So for instance, here you've got a new activity which is very different, but if I wanted to say, to change something of the main manifest file, I could do it right here. So let's go back to the main let's go to the Android view, it's easier. So if we go back to the main manifest file, who could we change? We could change again maybe the label. Do we have a label? We do. So we could very well say, oh, that's the activity label. Yeah, I was like wondering, oh, this is passing, how can it pass? So, well, let's first do it once. Okay, well. Of course, I need to resync. Can I rebuild everything? Okay, yeah, I made a mistake here. I don't know what I did, but why is it not finding R? I have. Okay, let's say that it worked. Let's continue. So here, if I was to say that I want to override the label, Android label, and I say something, whatever, again here I would need to say that I'm overriding the version in the application. So same thing, I would have to say tools, replace, and then I would say label. So what happens is that this overlay is replacing the label of the main Android application, which is itself replacing the label coming from the library. Okay, so you have all this hierarchy of Android XML files which get merged one after the other, and you need to understand that there is a hierarchy, and we go through these files one after the other to merge them into the main file. Okay, so I think that more or less concludes what I want to show, and I have only 1 minute left anyway. So feel free to ask me questions. Thank you for coming here today. There's a mailing list that you can use to ask questions once you start using it. And there's many more features that I didn't show today, like injection. You can replace certain values instead of using an hard-coded value like this. You could, for instance, say activity label, and then in your build file, whenever I can write correctly, in your build file, in your build.gradle, you could say my activity label is going to be called this, and then this will get injected and replaced automatically during the merging. So that's also a very powerful feature that you can, change the values of the XML elements through the build.xml.